Good day, everyone. Today we're going to discuss about imaginary and complex numbers. Before, we say that square root of -1, there is no real solution about it. Complex numbers are needed to find solutions of equations that cannot be solved using only the set of real numbers. That's the reason why we are going to add now the imaginary numbers. So in the set of real numbers, negative numbers do not have the square roots, right? If we will have the square root or in the radical form, inside the radical form, if it is negative, we will just say it is, and we are going to say there is no real solution about it. But here, imaginary unit we have invented so that all the numbers, all the values, we can have now a solution. So the imaginary numbers consist of all numbers bi, where b is a real number, and I is the imaginary we have unit, with a property that says that I squared is equals to -1. So when you're going to solve imaginary numbers that have exponents or exponents greater than we have 2, we can have this pattern, okay? So we have I raised to the power of 1. So if any variable, right? Remember, any variable raised to, we have a 1 or raised to 1 exponent, it will give you the same result, which is I. I squared, so the additional there is I squared is equals to, we have -1. I cubed is equals to -I. And I raised to the power of 4 is equals to 1. So therefore, these are the 4 we have basic patterns that you are going to remember to solve for imaginary unit or imaginary numbers that the exponent is greater than we have 4. For example, when you're going to solve problems that the exponent of the imaginary unit is greater than 4, you're going to divide now the exponent by 4. And whatever the remainder there is the same as the 4 we have cycles. So if there is no remainder, the answer is equals to 1. If it is I raised to the power of 4, okay, I raised to the power of 4 is equals to 1, which is when you're going to divide I raised to the power of 4 by 4, it is equal to 0, right? There is no remainder, so therefore the answer is 1. If there is one remainder, it will give you an I. Remember, going back to here, I raised to the power of 1 is equals to I. And then remainder of 2, it will give us -1. Remainder of 3, it will give us, we have -I, or I cubed is equals to -I. I squared again, it will give us -1. Okay, let's try to find some examples, okay? Try to solve some of this one. So for example, we have I raised to the power of 23. I raised to the power of 23, we're going to divide 23 divided by 4, which is, we will get, we have 3, or the remainder there is equals to 3, right? So therefore, you will have now I, -I, which is I cubed. 23 divided by 4, which is, the remainder is equals to 3, so therefore that is equals to I cubed, right? I cubed now, going back here, I cubed is equals to -I. Next, I 2006. When you're going to divide this one, there will be what is the remainder? 2006 divided by 4, there is 2 remainder, right? So therefore it will become I squared. So therefore we will have now -1. Find I 37. 37 divided by 4, we have 1 remainder. So therefore that is I raised to the power of 1, which is equals to I. This one, find I 828, which is divisible by 4. So therefore there is no remainder for that. So therefore if there is no remainder, therefore that is equal to 1. Got it? Again, I 23, remainder 3, I cubed, -I. Here we have I squared, -1. I raised to the power of, we have I raised to the power of 1 equals to I, and then here I raised to the power of 0, or I to the power of 4 is equals to 1. So these are partly of the complex numbers. So these are the whole, we have topics now of complex numbers or complex number system. So we have now the real numbers, rational numbers, integers, whole numbers, natural numbers, irrational numbers, and imaginary, we have numbers. Express now these numbers in terms of I. So when you're going to solve radical numbers involving negative inside the radicals, we are going to make it in terms of I. So therefore, we are going to multiply this one by negative 1, which is negative 1 is equals to I, right? So therefore, we will have now square root of negative 1 is I, and then square root of 5. So your answer now will give you I square root of 5. Next example. Negative square root of negative 7. So simplify first inside the radical. It will give us negative square root of negative 1 times 7. And then after that, square root of negative 1, okay, will give us negative I. And then after that, we get now negative I square root of 7. Next, square root of negative 99. We can factor negative 99, right? To 99, we have times 1. So that we can simplify square root of negative 1, which gives us I. But 99, we can factor it out by 3 times 3 times 11. That will give us 3I equals to, or 3I square root of 11. Okay? So as what I've said in the past, we have discussions that if the equation, if inside of the radical you can simplify it, you have to simplify it in the simplest form. Here, another examples, we have square root of negative 7, I squared of 7. This one is a perfect square, so therefore you will have now as negative 6I. And then here we have square root of negative 160 will give us 4I. Simplify this one, right? 16 times 10, that will give us 4I squared of 10. Okay? So there are some problems that you are going to practice more. Okay, so you have to practice a lot of problems so that it's easier for you to refresh all the formulas that you're going to use in solving complex numbers. So here, if you're going to multiply imaginary numbers or an imaginary number by a real number, it is important first to express the imaginary numbers in terms of I. Okay? So simplify first the imaginary, and then after that you're going to multiply. And then simplify the imaginary numbers as well with the exponent is greater than 1. Okay? So here 49i times 2, so therefore you will just multiply real numbers, which is 47, okay, 47i times 2. We give that one as 94i. Next, 2i times square root of negative 5. Simplify negative 5 first, which is equal to square root of negative 1 times 5. And then square root of negative 1 is equals to I. Right? So therefore you have 2i times I square root of 5. And then I times I, remember when you are going to multiply variable or any, we have variables, you are going to add the exponent, right? So therefore, any variable have always one exponent. So we will get now 2i squared, and then I squared is equals to negative 1. So negative 1 times 2 will give us negative 2 square root of 5. Next, square root of, or negative square root of 3 times square root of negative, we have 7. So because we will make this one as negative 1, right? So therefore that will give you negative I now multiplied by negative, but here we'll have I. And then negative I times I will give us negative I squared. And then I squared is equals to negative 1. So negative 1 times 1 will give us a positive result. That will give us square root of 21. Next, complex numbers. So complex numbers are, we have numbers that consist of, or a complex number consists of all sums of a plus bi, where a and b are real numbers and I is the imaginary unit. The real part is a and the imaginary part is bi. Okay, so let's try some example. When you're going to add and subtract imaginary or complex numbers, it's almost the same as adding and subtracting. We have polynomials. You can only add and subtract if they have common variable and the exponent is the same, right? It's also the same in complex numbers. When you're going to add and subtract, be sure that the exponent and the variable is the same. So here we have 7i plus 9i. Therefore, here is the same variable and the exponent is the same as well. So you will get now 16i. For example, we have negative 5 plus 6i plus 2 minus 11i. So here we have real number and a imaginary number. So therefore, you are going to add only the real number or real part, which is negative 5 plus 2. That will give us, we have negative 3 and 6i plus negative 11i. That will give us negative 5i. So that is the final answer. Another example, we have 2 plus 3i minus 4 plus 2i. Therefore, you will have 2 plus or 2 minus 4 and then 3 minus 2i. So therefore, it will give us negative 2 plus 2i. Okay, now the next part is how to multiply and divide complex numbers. When you're going to multiply, remember that you're going to add the exponent again, right? We have we have the power, or we have the multiplication rule of polynomials, which is you're going to add the exponent, right? am times a raised to the power of m times a raised to the power of n will give us am plus n, right? Therefore, it's the same here in multiplying and dividing complex numbers. When you're going to divide, you're going to find the conjugate of it. So we'll explain that one further later in our dividing complex number parts. So 3i plus 4i. Therefore, we have 3 times 4 and I times I. That will give us we have 12i squared. And remember, I squared is equals to negative 1. So therefore, we will have now 12 negative times negative 1 will give us negative 12. And then 7i squared. So therefore, it will give you 7 times 7 and then I times I, right? So we get now 49i squared, which is I squared is equals to negative 1. So therefore, your answer is negative 49. Next, 7i times 12i. So negative times positive, it will give you negative. So therefore, that is equals to 84, negative 84. And then I squared again is negative 1. So negative times negative becomes a positive result. And then here, negative times a negative becomes a positive, right? Therefore, you will have now negative 121. Okay? Next, what if we're going to multiply a binomial and a binomial of a complex number? So therefore, what you're going to do is the same, using the FOIL method first, and then we have the outer part, and then inner part, and then the last we have part. So therefore, we have 4 times 7 is 28, 4 times 2i is equals to 8i, 3i times 7 is equals to 7i, and then 3i times 2i is equals to 6i squared. Simplify values that we have the same variable. We can add both of them, right? And then I squared as well, we can simplify as negative 1. So therefore, you will have now as 28 plus 29i plus 6 times negative 1. So therefore, we get here negative 6. That will give us 28 minus 6 is 22 plus 29i. Next example. How about if we have 2 minus I times 3 plus I plus 10i, I mean. So you can pause the video first while you are trying to do your work. Okay, and then after that, try to check if your answer is correct. So we have 2 times 3 is 6. 2 times 10 is 20i. I times 3 is negative 3i. Negative times 10i, we get 10i squared. So therefore, you can combine this one as 17i. And then here, 10 times negative 10 times negative 1. So therefore, you will have now as positive 10. So therefore, your final answer will give you 16 plus 17i. Always remember, if you're going to solve the problems, okay, we'll just move a little bit here first. So when you're going to arrange the complex number, it must be real number and then the imaginary number. Next, okay, we have 5 plus 7i times 5 minus 7i. So this one is almost the same as difference of two squares, right? Therefore, you will have a squared minus b squared. That will give us equals to 25 minus 35 plus 35i and then minus 49i squared. Therefore, you will have to cancel out that, and then I squared is equals to negative. Negative times negative becomes positive. Therefore, you will have now equal to 74. How about if we are going to divide complex numbers? What we are going to do? The first thing you will do is you are going to find now the conjugate of each equation. Okay, so how to find the conjugate? The conjugate is just only the opposite sign. Okay, the conjugate is almost the same as, or we have the meaning of conjugate is the opposite sign of the operation of the given value. For example, a plus bi will give us a minus bi. If it is a minus bi, the conjugate now is a plus bi. So we'll try some examples. So we have 3 plus 4i. So we'll get now as 3 minus 4i. If it is negative 4 minus 7i, it will give you negative 4 plus 7i. If it is 5i, it will give you as negative 5i. But what if it will give you 6? 6 is just only real numbers, right? There is no imaginary, so therefore you can add that one as imaginary as 0. So therefore, whatever the value, it will give you the same result as we have 0, right? So therefore, you will have now 6 the same as 6 as well. Okay, let's try some examples. Okay, for example, we have negative 5 plus 9i all over by 1 plus minus i. So therefore, what is the conjugate? Conjugate is you're going to find, it's almost the same as rationalizing the denominator. In dividing, if you're going to divide numbers in complex numbers, you're going to use the denominator, which is now 1 minus I gives us 1 plus I over 1 plus I. And then simply distribute. So therefore you will have negative 5 plus 5I plus 9I plus 9I squared. Okay, distribute that one. FOIL method. And then here we have the difference of two squares. So therefore it will give us 1 plus I minus I squared. That will give us, simplify, negative 5. And then here is 9I squared, which is I squared is negative. We have negative 1. So negative 1 times 9 will give us negative 9. So negative 9 and negative 5 is 14. And then negative 5 plus 9i is positive 4. And then we have 1 minus I squared, which is I squared is equals to negative 1 as well, right? So negative 1, negative times negative becomes positive. So that therefore it will become now as 1 plus 1 gives us 2. And then here we can still simplify. We can separate negative 14 divided by 2 and then plus 4i divided by 2, which gives us negative 7 plus 2i. Okay? So going back here, so when you're going to simplify, be careful with the sign. Okay, so for example here, the negative I squared, right? If it is negative I squared, don't include the negative sign first before you're going to simplify the I squared. So I squared is also equal to negative 1. So therefore negative 1 times a negative becomes a positive. So therefore that is 1 plus, okay, 1 plus 1 here, which is I squared is equals to negative 1. So therefore that is how we get 2. Okay, last example. 2, we have minus 3i, 3 plus 5i. So therefore you will have now 3 minus 5i, and then simplify it with the use of FOIL method. So therefore you will have now 6, and then 2 times negative 5, 10i, 2 times negative 3 times 3, we get negative 9i, and then negative times negative becomes positive. And then the same here, we will have 3 times 3, 3 times negative 5, 5i times 3, we get 15i, and then we have 5i times negative 5i, we get negative 25i squared. And then simplify I squared is equals to negative 1. So therefore, you will have now as 6, okay, 6 minus 15 here, because this one now I squared times 15 equals to negative 15, right? And then 6 minus 15 is equals to negative 9. And then negative 10i minus 9i equals 19i. And then 9 minus 25i squared, which is 25i squared now becomes positive, which is here I squared times negative here becomes positive. So the answer now will give us negative 9 minus 19i over 34. If we cannot simplify, just leave your answer that way. Okay, that's all for the lesson for complex numbers. If you have clarifications and questions, don't hesitate to send an email, or we have comment your questions, okay, in the comment section. Thank you and have a nice day to everyone.